All right, guys, we are in Advanced Math Trig Mod 7. So Advanced Math Mod 7, we are going to finish up our logarithmic equations that we started on Friday. Hope you had a great weekend. For today's notes, top left corner, it is Monday, April 27th. So top left corner, 4/27/20 for the date. Again, it's Monday the 27th. The title says More Logarithmic Equations. Hopefully you printed out the worksheet from Friday that was attached on Schoology that had 20 logarithm equations on it. If you remember, the last thing we did, I did 1, 3, 5, 7, and 9 for our notes and your homework from Friday. The assignment that was due Monday at noon, so today at noon, was numbers what? 2, 4, 6, 8, and 10. Those 5 questions. Well, to finish that worksheet, of course, today I'm going to do 11, 13, 15, 17, and finally number 19 on logarithmic equations. It gets a little more challenging today. You gotta stay with me. Don't assume you're gonna know what you're doing and jump ahead and try the homework on your own. Watch the little 15-minute video, think along with me, listen, take your notes just like you're in class, and then try what will be 12 through 20 even for your homework. 12, 14, 16, 18, and 20. And that'll be 5 questions that are due tomorrow on Tuesday the 28th by noon, okay? Today, number 11, I'm just gonna continue on with our sheet here. Go ahead and write log of x minus 3 equals 2. Now, let me point something really important out. When you do see only one log in the problem, your brain should jump to the idea of Ben, right? So as soon as I see one log, I'm thinking good old Ben, which is base exponent number. Agreed? However, if your problem has more than one log in it, you can't bounce to the word Ben yet. You've got to condense, expand, combine, work algebraically until you get to the one-word log, and then kind of go from there. So be careful. Don't rush through these. Think about that all-important first step. First step on this one. Oh, there's only one log. So if I think Ben, remember every time you see the word log and do not see a base down here, it is understood to be a 10. That's a common logarithm. When it was ln, it was a natural log, your base was e. On a common log, your base is understood to be 10. So this is not going to be difficult at all. My base is 10. Follow the bouncing pen like we always do. I have a base, an exponent, and a final number. So my base is 10, my exponent is 2, and my final number is x minus 3. I'm not even going to need a calculator, agreed? Because 10 squared is, okay, careful. Some of you are missing homework problems, all right? Every time you miss a problem, you lose a point, which that's fine, no big deal. But if your goal is to get them right, then concentrate. 10 squared is not 20. 10 squared is 100 equals x minus 3. Add that 3 over to the left side, so x ends up equaling, of course, 103, and I'm already done. Okay? Now, careful. Look at number 13. I'll give you a second to write it down. The log of x plus 4 minus the log of x equals the log of x plus 2. Do not use Ben. You can't. There's more than one log in this problem. All right, for now, guys, I'm going to focus on the left side of the equal sign only. Do you agree that on the left side, if I said, describe to me what you see there, it's the log of m minus the log of n? Oh, remember when we did, again, the expanding and condensing? If you had the log of a quotient, remember the quotient rule? The log of m over n was broken down into the log of m minus the log of n. So if you ever see a subtraction, you're going to condense it into a quotient or a division problem. So do you agree that the left side is really the log of x plus 4 over x? I saw a minus in the middle. the log of m minus n, log of m minus the log of n, I change to the log of m over n. That's not that hard. You see a minus, you change it to a division bar. On the other side, we'll leave it go, the log of x plus 2. Now, good news. Guys, pay attention. We haven't seen this yet. There's a log on both sides. I have a log on the left and a log on the right, and the base of each log is the same, isn't it? So great news. You love when that happens, because now on this logarithmic equation, as soon as you get down to the point where you've got one log on the left and one log on the right, and they have the same base, those logs cancel each other out. So really, you've got x plus 4 over x on the left equals x plus 2, which is understood to be over what? 1 on the right. Of course, I'm pointing that out because I've created a proportion, and now I'm going to cross multiply to solve my equation. So if I take x times x plus 2, careful, I'm distributing the x. Do you agree that's x squared plus 2x equals, what's 1 times x plus 4? X plus 4. Now you're solving an equation that has an x squared in it. That's a quadratic equation, and of course you guys know the only way to solve a quadratic equation is to get everybody on one side, get all the terms on one side, and get it equal to 0, right? Get it in, quote, standard form. So I'm subtracting over the x, subtracting over the 4. So x squared, now that was plus 2x, but I'm minusing an x, giving me plus x. Minus 4 equals 0. Now, unfortunately for us, oh my gosh, if I went and tried to factor this into two binomials, right? Isn't that your instinct? Because it's a trinomial, I'm trying to factor it. I'd have x and x signs are different, and there's no way I can use 4 and 1 or 2 and 2 and have it equal my middle number. It doesn't factor, so we've got to use the quadratic formula. So if you've got a calculator that has a program of the quadratic formula in it, great. Obviously, A is 1, B is 1, and C is -4. If you don't have a program, we're going to do this by hand real quick. Okay, remember the quad formula? Do I have to write it down real quick? Opposite of B plus or minus square root B squared minus 4AC all over 2A. You're supposed to know that. You've used it enough. So real quick, here we go. Opposite of B would be the opposite of positive 1, which is -1, plus or minus square root box, B squared. Well, 1 squared, careful, is 1, minus, now let's do this in our head. We've got 4 times A times C. So we've got really -4 times 1, which is -4, times another -4, which gives me plus 16 in there. All over 2 times A, which is 2 times 1, which is 2. So we've got -1 plus or minus, obviously that's the square root of what, 17? So on my calculator, I'm going to go ahead and hit square root 17. I get let me see, probably 4.1, right? Yep, 4.1. So -1 plus or minus 4.1 all over 2. So, finally, here we go. Cover up the minus sign. Pretend it's not there. -1 plus 4.1 is what? 3.1 divided by 2. Oh, so if I push 3.1 divided by 2, I get 1.55. And then my other answer, -1 minus 4.1 is -5.1 divided by 2, creating some negative answer. That again, guys, a negative answer, when I go plug it into this problem to check it, you can never have a log of a negative number. That's impossible. So that answer is not going to be relevant. Wow. So who would have thought the only answer to this problem is 1.55? A little bit tougher today. You got to think your way through the algebra. Okay? All right. Next one. Number 15. Oh boy, I got ln x plus ln of x squared minus 8 equals ln of 8x. Oh, okay, what stands out here? Look, guys, that is a plus sign on the left side. Agreed? I've got the log of x plus the log of x squared minus 8. Remember that last problem? When it was a minus, we turned it into a division problem. When it's a plus, we use the what? Product rule. The log of m plus the log of n is really the log of m times n. So I end up with that dot connected scenario equals ln of 8x. Now, good news, just like the last problem, okay? I got an ln on the left and an ln on the right, so they cancel each other out, just like the last problem. So really, when I distribute here on the left, don't I have x cubed minus 8x equals 8x? And just like on that last problem that we did, I want to shove that number over to the left side and get this equation equal to 0. So I'm going to have x cubed minus 16x equals 0. Okay, now freeze. I'm going to remind you of a trick that Mr. DeMarco should have already taught you. If you're ever solving an equation and it's equal to 0 and you don't know what to do to try to solve it, because there's one on your homework that turns out kind of like this that doesn't factor, even though this one does, you can always solve this equation by typing it in as a function on your calculator and just looking to see where that function touches the x-axis. So guys, grab your graphing calculator, hit y equals, and type in that function, x raised to the third power, okay, and then what? Hold on, I gotta find the right buttons here. So I'm hitting y equals x raised to the third, and then minus 16x. Look at your screen, make sure you typed it in right. Now hit graph. If there's any issue on your graph, hit zoom 6, and it'll get a nice standard picture. And as you look at that picture, all you've got to do to answer this question, what's the solutions here? X equals what? Well, where does it touch the x-axis at? It looks to me like it touches at -4. Then it goes straight through the origin at 0 and then comes back up and goes through the x-axis at 4. Now look at your problem. If I took -4 and plugged it in, you can't have a negative logarithm. That doesn't work. Think about it. If I took 0 and went and plugged it in, and that said the ln of 0, guys, that's impossible too. Think about it. On a natural log, the base is understood to be an e. E raised to what power would give you 0? Well, that's impossible. You can't take 2.718 and raise it to a power and have it turn into 0. So that doesn't work. So the answer to that equation is 4. I would put a star by that one. That one is just like number 16 on your homework. You might need your calculator to type it in and see where does it touch the x-axis. Okay, I hope you're listening and following along with the notes. It's the only way you're going to really learn and be able to do the steps correctly on the assignment you've got. Now, what ends up being, I think, an easier problem, look at number 17 here. The log of x plus 5 equals the log of x minus 1 minus the log of x plus 1. I see on the right side, again, you got to think and follow your instincts. There's a minus, just like on the problem right above it here. Remember, the log of m over n equals the log of m minus the log of n. So, my first step here is to make this the log of a, what? M over n, a quotient. So you'd have x minus 1 over x plus 1. Oh, good news. I've got a log on the left. I've got a log on the right. So those logs cancel. That's happened 3 times in a row now. I've got x plus 5, which is understood to be over 1. equals x minus 1 over x plus 1. And now I cross multiply, correct? Now careful, I'm taking this entire denominator times that numerator. So you're going to have to double distribute and get x squared. Now watch this. Obviously x times x is x squared. X times 5 is 5x. 1 times x is 1x. So that's a total of what? 6x. Plus, and then 1 times 5 is 5. You're in pre-calculus here. I think you can take a binomial times a binomial, FOIL it or double distribute and get that answer. And on the other side, 1 times x minus 1 is x minus 1. Once again, we've got a quadratic equation. I'm taking those two guys on the right and moving them over to the left side. Shove them to the left, get everybody on the left side here. Got to get it into standard form. So I've got x squared. Now that was a plus 6x, but I'm minusing an x, giving me plus 5x. Agreed? That says plus 5, and I'm going to add over a 1, making that plus 6. And luckily this time, thank goodness, that trinomial, now that it's in standard form, when I go to factor it, I've got x and x. That plus means my signs are the same, plus and plus. And wouldn't I use 3 times 2 because the 3 and the 2 add up to equal the middle number of 5. So it did factor. I do the old let's split them up and set them both equal to 0 trick, right? The old separate those since they're dot connected. I've got x plus 3 equals 0, x plus 2 equals 0. So x equals what? Negative 3. And x equals what else when I minus him over? Negative 2. Now careful. Just because you got a negative answer doesn't mean you cross it out and say, oh, it doesn't work. I can't have a negative answer. Guys, the rule is you can't have a negative logarithm. So let's take a look. If I took negative 3 and plugged it into this problem, right here we'd be okay because negative 3 plus 5 would be what? The log of 2. But as soon as I see the log of, and I plug in negative 3 minus 1, and it creates negative, I can't have the log of a negative number, so that's no good. Negative 2 would also create a negative number by that log. That's no good. So, I crossed them both out. Sorry, couldn't see that. I took negative 3, plugged it in there. It created a negative number, so I crossed out, said it doesn't work. I took negative 2, our other answer, plugged it in there. Negative 2 minus 1 is negative 3. Again, you can't have the log of a negative number, so that doesn't work. So, oh my gosh, think about that. We did all that work, got what we thought were the two best answers in the world. Even they didn't work. So guys, you end up writing, oh my gosh, no solution to that problem. It doesn't have a correct answer. Finally, last one I'm going to do on the worksheet, number 19, looks like this. Now careful, there's only logs on the left side, agreed? And once again, we see a minus in the middle. So I'm thinking the log of m over n, we split into the log of m minus the log of n. So I'm going to condense this into the log of 2 and then have what? X plus 5 over x minus 2 equals just 3. Now don't cross out the log, right? There is no log on the other side. Oh, but because there is only one log, you're thinking, Ben, see how your brain is trained to think here. Every time I have an equation and there's only one log involved, I'm going to use base exponent final number. So my base is 2. My exponent is 3 equals, that's my final number. Agreed? This is understood to be over 1. Now, obviously, 2 to the 3rd power, careful, that's what number? That's 8, isn't it? 2 times 2 times 2. So if this is really an 8, and I cross multiply it times that x minus 2, I get 8x minus 16 equals, and then I cross multiply here and get what? X plus 5 Oh, good. It's not even a quadratic equation, is it? It's just a nice linear equation from Algebra 1. I'm going to minus over the x, giving me 7x minus 16 equals 5. Add over the 16, get 7x equals 21. Divide by 7, we did it. X equals 3. Cool. So guys, you are experts at solving exponential equations and now logarithmic equations. And the reason you got to know how to do that, there are applications for this. I'll show you one application tomorrow dealing with growth and decay and carbon dating and scientific formulas. And then on Wednesday, I'm going to show you an application in the financial world where we're talking about the growth or decay of a bank account, a savings account, a loan investment, things like that, and show you how exponents and logs can be used in the business or financial world. So the next 2 days, just some cool applications where you'd actually use this stuff, okay? All right, great job. Your homework, of course, then, since today is Monday the 27th, this is due tomorrow, Tuesday the 28th. Big deal, 12 to 20 even. Try 5 logarithmic equations. Take your time, talk your way through them, circle the answers. Shoot me a picture of that by tomorrow at noon. Not this Friday at noon. We're not on your schedule, at your convenience. You watch your video each day and do your 20-minute lesson. Big deal. It's just like we're in school. You got to keep up and kind of go with the flow and get things done as expected, okay? Great job. See you tomorrow.